say? Okay, so a solution, right? Jaden, what do we mean by a solution? Yeah. You have no clue what we mean by a solution. We spent 3 weeks on it. You took a test on it. You don't know what a solution is? None? I don't believe you. Well, then you need to write this note down next to number 2. We've done this multiple days every single week, right? Okay? Well, Shannon, what do you remember about a solution? Okay, so it makes an equation or what else? Inequality, true, right? If you have a solution that makes the mathematical statement, which that can be an equation or an inequality, right? So, but it makes the mathematical statement true. That is the most fundamental idea. Jaden, you didn't know this, but you're not writing this down. How does that make sense, bud? This is the most fundamental idea that we dealt with when it comes to equations and inequalities. Jaden. Come on, write it down, dude. Okay? This is the most fundamental idea that came up with solving equations and inequalities. You got to know this. Notice how Lynn solved the equation because what point is going to be on the number line?
1.
1, right? That's the critical value. So how do we determine if x is less than 1 or if x is greater than 1?
Plug in numbers.
Say that one more time.
Plug in numbers.
Plug in numbers, right? Don't make it more difficult than that. Should 1 be a solution, right? Should we have an open or closed point on the 1?
You could say
Open.
Okay. Open? Is that what we said? Okay. Because if it's open, that means it is not a solution. And you can check it. 15 minus 1, is that less than 14?
No.
No. Right? 14 is not less than 14, it's equal to it, right? So that's going to be an open point. Any ideas about which direction we should probably shade? Based maybe on the inequality? To the what? To the right? But it's a less than. So why to the right?
Because the bigger the number, the more we'll subtract.
Say that one more time.
Because the bigger the number, the more 15 will.
Okay, notice there's logic there of just, hey, the bigger the number, the more you're subtracting to keep it less than 14. Also, if we end up dividing by a negative, what does that do to the direction of the inequality? Flips it or reverses it, right? So let's test that to make sure that that's true. So let's test maybe a 4. 15 minus 4, is that less than 14? Yes? So which direction am I shading? That's it. So the solutions are x is greater than 1. Notice there's a procedure, but the procedure needs to be based on the concept at play. The concept is a solution. What makes the inequality true? Join this little lesson 20 homework. Let's do today. Do you need a copy of it? Yeah, it should be. There's lesson 20. Look behind that. Keep going one more page. So let's talk about number 3 a little bit. Just a couple people asked questions about this one. A cell phone company offers 2 texting plans. People who use plan A pay 10 cents for each text sent or received. People who use plan B pay $12 per month and then pay an additional 2 cents for each text sent or received. And this is a question that Gracie asked me about yesterday. Because if we're talking about $12 per month, are you going to repeatedly incur that cost? Yes. However, looking at both of the plans, what's the independent variable actually? What's the independent variable?
12.
Variable.
Oh.
I mean, it could be X, but what would the X represent?
Oh, the month, I mean, not the months, the, what's it called? How many times you text the text? Each text sent and received or whatever.
Notice how it's 10 for, first off, is 10 a variable? But is 10 a variable?
No.
No, that's a number given to you, right? It's 10 cents for each text sent or received. And I know that's my variable, the number of texts sent or received, because again, an additional 2 cents for each text sent or received, right? Notice how that's the idea that keeps showing up both times? Because how often do you pay your cell phone bill? And by you, I mean your parents probably, maybe some of us do pay it, but every month, right? So that $12, you're going to incur that multiple times within that 1 month? Are you going to pay $12 multiple times in 1 month?
No.
No, right? We're paying it every month, so the 12 is only happening one time. So writing an inequality, how would I write an expression for plan A?
You would, do, for plan A, 10 cents for each text, so 10x.
Okay, what do y'all think about that? Yes? You're repeatedly adding the 10 cents, right? There's one thing I would modify about this expression though. Right? 10 cents is not, if we put 10, what do we probably really mean? $10. Are you paying $10 a text? I pray not, right? P.S. Did y'all know that you used to have to pay per text? Like that's a more recent thing of like, once data became the big thing, cell phone companies charged for data and not for individual text. But yeah, when I was growing up, I was not allowed to text because my parents had to pay for every single text that was sent.
They would probably make a lot more money if they did it by the text, or people would just stop texting.
They would start, but here, and that's the other thing, if you think about iPhones and stuff like that, can't you use Wi-Fi to text? Right? So then at that point, the texting doesn't make sense to charge for it, right? But 0.1x, what would be an expression for plan B?
Oh.
12.
Yeah, 12 was 2x.
0.02x. Remember, again, we want that not $2, 2 cents. And we're trying to show that which one is cheaper. Plan A. So do I need a less than, a greater than, less than or equal to, greater than or equal to? Less? Why is it not going to be less than or equal to?
Well, it ain't equal to, I
I'm trying to show it's less than.
It's cheaper, right? So don't forget on the homework you still need to explain the inequality, explain where it's coming from. Now that we have the inequality written, do we think we can solve it for B on our own? Yes?
Yes.
Okay. Solving the inequality, don't forget, how are we going to represent our solutions? Y'all, how are we going to represent our solutions?
Number line.
Number line, how else?
Interval notation.
Interval notation, okay? So make sure you represent your solutions like that. By the way, don't forget, I am passing back the test tomorrow, meaning you can start tomorrow coming in to work on test corrections, but I think some of us, I think Jelani, Nathan, and maybe one other in this class need to make that test up still. Tomorrow's your last day to make it up before I give back the test. If I give back the test, you can't take the original test because it's already out there. You'll have to do the makeup test, which means you won't get a chance to have a makeup test. Yeah. 3, 2, 3, 9, and 10. Did I put number 9 on this one? I didn't think so. Don't do number 9. We haven't done systems.
Where's the number 9?
We just did it on
Where's
Friday.
number 9? Number 9 ain't even on
There's
there.
no number.
That's what I said. But someone had number 9 in the
I think they just put a random number because you.
Yeah, 9 confused me a little, which it may be a number 9 from a different homework, not less than 20. If that's the case, kind of talk with me. But let's look at number 10, okay? Again, so like here, what is the solution set? So why would 10 be confusing?
Because it has fractions.
It has fractions, right? But what mathematical operation is a fraction?
Division.
Division. So what can I do to undo division?
Multiplication.
Right. Don't make it more complicated than that. I could just multiply. Specifically, what could I multiply by? 2, right? But I can't change the inequality. I want an equivalent inequality. So when I multiply by 2, what do I need to do?
Do it on both sides.
Do it on both sides. So would this be correct? I would get 2 divided by 2 is 1. X plus 2 is greater than or equal to negative 7 minus, that gives me a 1, so minus x. Is that equivalent?
No.
No, why not?
One's a 2 and one's a negative 7. And that's not equivalent.
Well, but I mean, I multiplied both sides of the inequality by 2. Or did I? Why not? Did I multiply that 2 by the negative 7? No. If I'm multiplying both sides of the inequality by 2, right? I gotta multiply the whole right side by 2, right? That's the property of so technically be property of inequality in this case, but I'm gonna distribute, right? So I get negative 14 minus x divided by 2 times 2. I'm just showing that distribution there. That's a 1. X plus 2 is greater than or equal to negative 14 minus x. Does that look less scary? Yes? By the way, can you solve it as an inequality? Yes. What did I recommend though? Equation. Remember, that's what they did in number 2, is they had an equation, they solved it to find the critical value, right? I would have technically done this as an equals to, right? Find critical value with equation and test around, right? I'm going to solve it as an equation. I'm going to test around it because all I care about is finding the solution. So if I find the critical value, I can test around it pretty easily. Okay. Yeah. Okay.
I'm still writing
You're good. I still have to collect the stuff again. That's the opposite of one. Can you see the red right now? Or do I need to get rid of the screen?
Wait a minute, did I get that one right? Was the answer B?
I got it wrong still.
Hit an A because that's where I flip the sign.
Well, if you remember,
Well, I
if
had
you
it
do a critical value, you just test around the critical value instead of worrying about reversing the direction.
Yeah, so is it?
I would, again, remember, look, I'm solving it as an equation. When you solve it as an equation, what critical value do you get? Negative 8. So what number has to be on the number line? Negative 8, right? I might even just put it in the middle at this point. Negative 7, negative 6, right? I'm working towards that 0. And then negative 9, negative 10. And so you're thinking that it's greater than or less than CD. And you said A. Are you thinking it's greater than or less than? Less than, right? So you're thinking it's over here? So that means something like negative 10 should make the inequality what? True? So what was the original inequality? Was it x plus 2 divided by 2 is less than or equal to?
Yeah, right there.
Okay, so something like negative 10. By the way, do you know why I chose negative 10 and not a negative 9? What am I going to end up doing? Dividing by, remember, to solve it I multiply by 2, right? But if I'm determining if that's a solution, I'm going to divide by 2. Do you want to do an odd number divided by 2? Me neither, right? I'm going to make my life easier. So negative 10 plus 2 divided by 2 is less than or equal to negative 7 minus negative 10 divided by 2. So that's negative 8 divided by 2 is negative 4 is less than or equal to negative 7. That's plus 10, so plus 5. Is negative 4 less than or equal to negative 2? Is that a true statement?
No,
It's less than. So is it less than or equal to? Yes. Right? Oh, you're saying it's supposed to be less than, not less than or equal to?
No, yeah, less than or equal to.
Okay, yeah. So notice, there we go, right? But this way you don't have to stress about memorizing, am I supposed to reverse the direction of the inequality or not? A lot of students make mistakes and forget that. Just find a critical value, right? And test around it to determine where the solutions are. Okay? Yes, ma'am. Huh?
I got negative 16.
Did you forget to divide by 2?
For which one?
Yeah, you gotta go.
I
Because
don't
you
know.
should have gotten a
Negative
2x.
16 equals negative
Look,
2.
you should have gotten a 2x
Oh,
here,
okay.
right?
Oh, I didn't do that.
Yeah.
I minus by 2 first.
And that's fine. You just have to remember there's an x and a minus x. So when you add the x, you get a 2x. Right?
Okay.
Yeah. So be careful. Well, I mean, notice it's going to the left of negative 8, right? Is to the left less than or greater than? It's less than, right? So it's x is less than or equal to negative 8.
So Mr. Kenny,
No.
10 is A now?
I don't know.
Do you swap the sign?
I don't know.
That's not helpful.
I'm sorry.
Because I divided by the negative 2 or whatever, but you said if we're doing it the other way, where it's like the range or whatever, it's like on the number
Look,
line thingy.
What's the critical value?
Yeah, that. I don't,
Negative 8, right?
yeah.
Remember, I'm not worrying about the inequality. I'm doing it as an equation to find the critical value. The solutions make the original inequality what?
True.
So I test numbers. I tested negative 10. Negative 10 gave me negative 4 is less than or equal to negative 2. Is that a true statement?
Mhm.
Yes. So I'm shading to the left. For all my solutions are to the left of negative 8. So Gracie, I already gave you all this answer.
I don't know, but I couldn't.
Right? That's what we need to recognize more than anything else. But we got to get started with today. Already further behind than I thought we would be. But hopefully that helps us. I will say this. You're going to have some homework due on Monday. But because I was behind on giving you all a chance to ask questions about lesson 20, I'll let you turn in the lesson 20 homework tomorrow free of charge for being late. If you have it today, great. Okay? But that was my fault for being late on giving you a chance to ask questions. You can turn it in tomorrow. You still have some homework due on Monday. It's very short. We good? Ready to go? Alright, so we're going to wrap up the bear hunting activity. Then we're going to do the is anchored putting better. And then we're going to do a little bit out of the textbook that I gave you yesterday. Really quick note. So remember yesterday we voted on a song choice. And we voted on Bohemian Rhapsody, right? Do you remember that detail?
And she didn't flip the sign.
Mostly because we didn't know enough else. I did get a second song for my later class, my third block. And the song that they originally chose had the N-word a lot. And I'll be honest, as a white teacher, I did not feel comfortable playing a song with the N-word regularly. I felt like that would be inappropriate. Is that, yeah. I was like, they wanted Tombstone by, is it Rod Wave, is that right?
Oh.
Yeah.
I love that.
His concert.
And like, yeah, I saw that. And like, let's be real, I thought the song was really powerful. I thought it was very relevant to life today, but I was like, as a white teacher, that'd be really wrong. Plus, I'll be honest, I really wish we'd stop, and then by we, I mean people would stop using that word. because like I know that the black community took on that word and made it something that's less harsh, but the origins of that word is horrific, right? Like, do we know the origins of the actual N-word? Yes? Okay? Because like, to me, the idea of like, literally a slave owner saying that to a black man to say, you are ignorant and you will forever be ignorant, is horrific. And like, that's something I don't want to perpetuate. And I talked about that with Miss Anderson, who used to teach here, so we're close friends, and she agreed with that sentiment. So I'm not doing that with them. But an alternative that does deal with some similar issues is This Is America by Childish Gambino. And so that's an option as well if we want to look at that song. So that may come up later today or tomorrow. But we have those two songs to look at. So I'm going to take the changes out because we talked about that yesterday. P.S. I forgot to write the active participation or collaboration grades down yesterday because my new placement student, she's only coming third and fourth block, so y'all won't see her probably. But she showed up and I had to run down there. So I didn't do the active participation grades yesterday. They will start today, right? So we need to be working actively with our groups to learn and grow. And don't forget, this is the main point of what we're trying to do with these first set of lessons. We should wrap them up pretty easily today and then get started on the next set tomorrow. But we need to know the difference between what two types of studies? Observational and experiments, right? They have very different goals, right? And they also have very different issues that we're going to try to deal with, the idea of bias and confounding. And so we'll talk about that today really quickly. Let me send out the data from yesterday one more time. So first block, bear hunting. And I have to send it out separately because y'all had different data than third block did. So I know there's a level of discomfort with getting used to using the calculators. We'll continue using them to get more comfortable with those ideas. But here's something I do want to show you or to point out. There's a couple of things that I'm going to do. So first things first, I do want to remind us of this, okay? Yesterday, to start, we expected the brown M&Ms to be approximately what percentage of all the M&Ms? So the proportion would be 0.049, right? Which is roughly what percentage? What? 5% roughly. Is 0.05 is the proportion, but the percentage times 100, right, would be 5%, right? Because remember, and this is, I should have had y'all write this down yesterday here, right? What was the goal of this activity, right? When we went outside and we went along and we counted the colors of each M&M, or called out the colors of the M&M, what were we trying to determine?
How many bears were in the forest?
We're trying to make a prediction, right? So make a prediction about what?
How many bears?
Okay, about the, I'm going to say relative frequency. Do y'all know the difference between relative and just plain old frequency?
The frequency is like relative, like it has a limit of like a small like frequency, like a relative one, and a normal, I don't know, that's a guess.
I mean, that's fair. So let's look at this really quickly. Yeah. No, I mean, use the idea of relative. So I want you to notice this right here. How many total brown M&Ms did we have when we went outside? 28, right? How many brown M&Ms did we have when we were inside? 38, right? Which that seems like a whole lot more, right? But exactly how much more is it? Well, it's hard to tell. Notice 38 is out of how many total M&Ms? 300, right? If you just count the frequency, it doesn't account for how many total M&Ms there were. We really almost had as many brown M&Ms the first time around, but how many total M&Ms were there? 575, right? Those are very different in their total amounts.
I was right, relative like a smaller, like,
Well, so like a relative frequency is going to be a proportion which is out of 100%.
Okay.
Okay?
And then not relative would be not
Just the
of 100%.
Pure count,
Okay.
right? So the frequency is the pure count, the relative frequency is a proportion or out of 100%, right? So make a prediction about the relative frequency of each M&M color. And almost, and we say of each M&M color, we just mean in the world, right? So for all M&Ms. That's important, right? Because what is the goal of an observational study, right? We have just observed how many M&Ms there were, correct?
Mm-hmm.
Okay? So what is the goal of an observational study in general?
To observe.
Well, we're going to observe in order to do what? Make a prediction, right? In general, I want us to make sure we define this idea. The goal of an observational study is to make a prediction. Does anyone know what we would label every M&M in the entire world? Starts with a P. About the population, right? So in statistics, and someone said it earlier, there's an S word that represents the small group we have. The sample, right? So we're going to use a sample to make a prediction about the population, right? So the goal of an observational study is to make a prediction about the population based on a sample. The goal of an observational study is to make a prediction based on the sample. Okay, I'm going to leave this part right here as a part of math literacy. I'm actually going to show you how to make a graph of this data on the TI Inspires so that you can start to see how to do that on your own. I am then going to email you the graphs and ask you to compare and contrast the two different sets of M&Ms. Does that make sense? I'll do one as a bar chart. I'll do a bar chart for both and a pie chart for both. We all good? Yes? Good talk, yay. All right. From there though, right, our samples were very different, weren't they? Originally, we expected what percentage of the M&Ms to be brown?
0.04 or something about
Which would be what percent?
4%.
5% roughly, almost 5%. Was that what we saw when we counted within our groups? No, very much no, right? When we counted within our groups, what percentage were brown? 13%. That's very different percentages, correct? Okay? So, and note, I will point this out, all the percentages were a little bit different, but the point that we're focusing on is the brown ones, and I'll explain why in a second. So why were the samples different, right? And so I might make a note here, 5% for brown M&Ms outside, or went outside, versus 13% when inside. Okay?
We write that under why were the samples?
Yep. So I'm making a note about the fact that they were different. There's more that you want to write when we make these graphs in a second for the math literacy part. But why in the world was there such a big difference?
The bias.
Okay, we talked a little bit about bias, right? So there was something that was creating bias, but think about what was happening outside. What would have caused us to significantly undercount the number of brown M&Ms?
You made us run through it instead of slowly let go.
But then we would have miscounted the red and the green as well, right? But we didn't miscount red, green, or
We didn't do them
yellow.
one by one.
Huh?
Do them all together.
Brown
Okay.
blends in
And
with
that
the grass.
stressed me out.
Oh, you put like 4 of them in an ant bed, so we all stayed away from those.
That wouldn't have made that big a difference. It's not that the brown mixed in with the grass.
Dirt.
Brown is pretty close to dirt, right? And what were the M&Ms sitting on?
Dirt.
Dirt.
Old grass.
So why was it hard to see the brown M&Ms? Because they blended in with the
Dirt.
dirt, right? So there was bias involved, okay? And let's just make this note at first. The brown M&Ms were hard to see because they blended in, excuse me, with the dirt.
What does it say after outside?
Versus, that's a V, thank
Oh,
you.
that was US.
Right, versus, right? But the brown M&Ms were hard to see because they blended in with the dirt. So, if I were to go outside and redo the activity, do you think we would get the correct percentage of brown M&Ms, or would we still be off?
It'd still be off.
It'd still be off, because it'd still be hard to see them, right? I'll tell you, I've done this activity multiple times. The brown M&Ms, when outside, have always been less. That is the definition of bias, right? So bias, that is when the study is conducted in a way so that the sample consistently misrepresents the population. Okay. Bias is when the study is conducted in a way so that the sample will consistently misrepresent the population. That's a major issue, right? Because what are we trying to do with an observational study?
Is it accurate as possible?
Be as accurate as possible in what? What are we going to try to do? Make a, not an estimate,
Prediction.
a prediction, right? We defined it over here. We want to make a prediction about the population. But if our sample doesn't look like the population, how accurate is our prediction? Not very, right? Bias is a major issue within observational studies because we want to predict the population, but the study is conducted in a way so that the sample consistently will misrepresent the population. Meaning if I do that study over and over and over again, I'll still miss the population. Does that make sense? Okay? So there are a few different types of bias, and so you might need to bleed into the final notes with this. This type of bias specifically is a measurement bias.